I will talk more on Linux Kit because Nipendra has already touched on multiple aspects. I will just try to uh, bring some clarity around where the Moppy stands and where the Linux Kit stands. So, my name is Ajit, and I'm a part of Docker Captains program. We try to. I have a great fund of writing blogs about the new technology which comes into the market, and especially for Docker. And then yesterday only we got 17.06 got GA. So if you have a Mac machine, you should be able to see that it should pop up saying like the latest release has come. So I'm currently working as a senior system development engineer at Dell EMC. Uh, Inside Dell, it's not my kind of a full-time job into the Docker, but it is just a matter of interest, which I've been doing, but a lot of POCs around Linux Kit, yes, and the Docker, because there are a lot of application, system management application, which we build inside Dell based on the Docker. So let's get started. So this is an agenda. I'm going to talk about Linux Kit and what problem it solves. So when any new technology comes, right, we usually, it's like we try to explore it, but it is very important to know what problem it is solving for us. A brief about Linux Kit tooling system, and then YAML file. I think Nipendra has covered most of the stuff. The Linux Kit supported platform. So today you have a lot of platform which you can experiment Linux Kit on. And it is just a 2 months old project, right? So this is nothing which is, and Linux Kit is most probably a development kit developed for developers rather than the end users. So don't expect it to go into the production soon. Moppy Playground. So this is the new website which has been this new platform as a service which has been launched by 2 of the Docker captains. So if you have used Play with Docker, the same interface, and they have tried to make it. If you want to try it, Moppy and the Linux Kit, you can go ahead and open it up, and the environment is ready. And I have one recorded demo, but I will go live for this. And this is probably, I will see if I have time, I can talk about this. So let's start with the problem statement. So 1 year back, uh, in the last DockerCon, right, there has been a lot of ask around the Docker native solutions or the platform, right? One of the user comes and say like, I'm a great fan of AWS. I want Docker on AWS. And then the other community ask was on Google Cloud Engine. And then some of the guys who are exploring in the Mac, they want to use VirtualBox. So the same thing for the VMware community. They wanted to know that I want a Docker to be like seamless. It should install it, right? So I want Docker for X platform. So then based on that, based on the community ask, the Docker started shipping the Docker for Mac, Docker for Windows, Docker for Azure, Docker for AWS. And now all these cloud platforms have a proprietary application or OS which is running. And that created a lot of problem here. Okay, so the problem was non-standard Linux OS, which was running into it. Now, if you are using AWS, you have AMI instances which you run, and when there are users who are trying to run some application, they find that the base operating system itself, they have to install the multiple application. Think about the security point of view. When we say Docker is not secure, it is all dependent on the host operating system where it is running, right? If the host operating system is not secure, your containers won't be secure, right? So what the Docker team came up like, they focused on the 3 parameters: portability, security, and incompatibility. So you should not you should not spend a lot of time in bringing up the host operating system which is capable of hosting your containers, right? In terms of security, in terms of portability. But the other problem which they faced is this term, which has come multiple times. If you hear any of the Moppy or the Linux Kit presentation, this is a one slide. And this goes back to 2011, where Netflix said that in the cloud, we know exactly what we want a server to be. And if we want to change that, we simply terminate it and launch a new server. And it makes sense, right? Today in the data center, if we have a number of servers, right? And if I have 500 servers, in one server it gets problem, the technician is not going to come and troubleshoot that. He will replace it. The same thing is being done in the cloud environment itself. If you have anything, so one of the problem which the Docker team faced is when you have an application running, right? And suppose you have an automation tool like Ansible and all, where your servers reboots. Once it reboots and comes back, your container has to up. But it looks like there are certain there are a lot of problems which the community faced or the users faced, because your containers might not come up because of your host operating system. First the host operating system has to come up, then your containers come up, right? So this was one problem in the cloud. They face that what they want is just go and replace it. So that is what we call it as a immutable. It's like you you can't, your the Moppy tool is going to build your system where every time you reboot it, it will basically have the same system and the same host operating system without any further changes. Because when you have a server which is running from past 10 years, you don't know what changes has been done to that. But when you build some kind of a base operating system through Linuxgate, you know how the server is going to come up, which services, because everything we are defining the YAML file, right? So these are the three parameters which the Linuxgate brings. Linuxgate is basically a container native toolkit. We are trying to build a container host operating system. When you say Docker, it talks about the application. Here we are building a container native host operating system, and this is building a three parameters: the lean, portable, and secure. Yes, we always want. So if you say the containers which are running on the Windows machine, and Windows machine itself is like a 40 GB base operating system, it's like you need containers. Containers are small, but your host operating system is heavy, right? So minimal size, minimal boot time, it should come up in seconds. And this is very important part which I am going to discuss in the next like 20 to 25 minutes. All system services are containers. Just imagine you are setting up. Just last week I was trying to build up an environment where I wanted to pixie boot. I want to Dockerize everything from starting from your server comes into the data center, and when you pixie boot it, right? Shall so we try to build a pixie boot container itself. So it will pixie boot, and your Puppet is also running, and then it is trying to push all the containers into it, right? So how good it would be like when your whole services is a container itself, your base operating system is container itself, right? You have a containers running, and your base operating system is also a container. Everything can be removed and replaced. It is in your hand. Just imagine which you have like 10 years back when someone say like, can you build your own Linux operating system? How difficult it is. Like you are building your own Linux operating system. You start from the scratch, right? Today you can build your own operating system through Linuxgate. Everything you want to do, you can customize it. You don't have to dependent on the proprietary vendors for including the packages or all. You can build your own operating system as per your requirement. And this Linuxgate, basically today, this is an effort which has been going on. So ARM support is coming. Today we run it on desktop. IoT is something which is there is a bug which is raised for this, and soon you will see it is running on the Raspberry Pi. Bare metal, yes, the bare metal today. I have tried it on the Dell server, and there is one Docker captain who is from HP, and he has tried it. It works great. All you have to do is build a kernel module with a particular RAID controller driver, and it should work. And on premises and in the cloud, already we have so many blogs which is written on AWS and Google Cloud platform. And security is one aspect where there is a weekly meeting for we call it as there are like security group which has been formed. So I don't want to touch that because I have not explored that area. But yes, there are some eBPF, if you have heard about those, not the SELinux and part, but there are other new security configuration which has been pushed, and we have a Docker content trust also on that. So talking about the GitHub statistics, this is like for the first week of after the Linuxgate was announced, in the first week itself, it got around 2,000 plus stars, and there has been like 3,000 plus commits, contributors. The external contributor itself is like it's 28, and the number of blog posts, yeah, there have been a lot. So this project has really taken a kind of a momentum in the next 2 months. in last 2 months. So I want to focus on the tooling system. This should give you a clear picture where what we are trying to do with the Moppy and Linux Kit. So Moppy is basically a tool which assembles, which builds your complete system, right? So you have a particular command called as a Moppy build, and input to it is a YAML file. And so Moppy is a tool for assembling a customized, modular, and containerized application. And the input to it is the YAML file. So whatever it's a one single YAML file. You go and define what your operating system should look like, and you just run this command, and it is going to give you a particular images, which could be a VM images in terms of cloud, and then you do a Linux Kit run. So Linux Kit is basically used to push in case, suppose if I am developing some images in my laptop, and if I want to push it to AWS, right? So I will use Linux Kit push first to push it to a particular S3 or the Google storage uh, platform, and then tool, and then it will go to the Google storage. It will push to that, and then from that you can do Linux Kit run to bring up the instances. So in terms of cloud, you have Moppy build, Linux Kit push, and Linux Kit run. But if you are doing in a laptop, it is simply Moppy build and the Linux Kit run. So Moppy is a tool for assembling, and it's building a kind of an images, VM images, whereas Linux Kit is to push and run the images. Yeah.
This all would be happening when the OS is already there, right? This Linux Kit will be running on the OS. How about you said that you have implemented it on physical bare metal? So how would this Linux Kit be working with respect to bare metal?
Bare metal. Okay. So suppose I developed I wrote a YAML file for my bare metal, right? So we are using a protocol called as we have used an API called as Redfish, and that Redfish is basically going to talk to the iDRAC, mount this particular ISO, mount the ISO, and then run it.
I think the idea is that the YAML file of Moppy will get the ISO as a renting image that you would use.
Yes. So you create an ISO and you push it through API to the bare metal iDRAC section. We call it as an ILOM in terms of ILO or iDRAC, and then that gets mounted to the virtual media and it runs it.
And you said that we can include what are the features we need through an ML file.
Yes.
Right. So if I say I do have I need some GUI features just for one of the application. So basically, are the packages, where will you get the package, through internet or?
This one you're talking about?
Yeah.
Linux Kit. So Linux Kit is basically you have all these images which are stored in the Docker Hub. Okay, so I have a slide. Let me show you. Okay, so if you see here, Docker search Linux Kit, and you grab the Linux Kit, you will see these images basically placed in the Docker Hub.
Okay.
So in the earlier, the YAML file was looks like a very busy, means a very heavy kind of work, because you are doing everything and you are adding the capabilities and all. Now there is a folder called /package under the Linux Kit repository, where you can go ahead and add all those parameters. So your YAML now looks very clean. Earlier it was like, so you can go ahead and define all the images, and it will pick up the images from here. Okay, but I can go ahead, and this is a standardization which they have brought. Okay, but I can use my own image. Suppose I have Nginx, a customized Nginx, I can go ahead and add that. That should also work.
And we can add and remove the properties to these particular images. Let's say these particular, whatever there is, they're available in a hub, Docker hub.
Yes.
It has some 1, 2, 3 features. I don't need part 3.
Yes.
I can remove, right?
You can build your own image, right? That's always the
You
case,
can
right?
create your own image, and lastly, we didn't have a RAID controller driver, so you can build your own kernel also there. So there is a project which they have added 2 weeks back, the kernel config.sh config project, which you can go ahead and make the changes. I might have a slide for that. It's not visible. Okay, I will go through the supported platform. Today, when you talk about the cloud platform, you have AWS, Google Cloud Platform, Azure is something which I haven't tried, but it is there. I have a blog written for AWS, Google Cloud, VMware is coming up, and we have a bare metal hosting company called as Packet, where if you want to run try something on the Raspberry Pi, maybe it is a you have to pay for this, but I can push the Linux kit to that particular Raspberry Pi and bring it up. So I haven't tried that, but AWS, Google Cloud, Azure, VMware, and in terms of local hypervisor, we have a HyperKit and VMware vCenter. We can push it to the vCenter. So I'm planning to write a blog on this, and yes, the KVM is already there, like Hyper-V. Hyper-V talk about the Linux. If you want to bring up things inside the Hyper-V, you can try it out. So you will find all these YAML file under the Linux Kit repository, under the examples folder.
If I have a ISO image that I can write on a Raspberry Pi.
Yeah, so the packets actually they provide some kind of remote console for the Raspberry Pis where you can go and push it.
I think ARM support is still not there.
The
Right?
Raspberry Pi support is still not there. Right? Still not there.
ARM's not supported.
Yeah, ARM support is not there. But yes, there are few things which is working and few things which are not. Still, you can see the issue under the Linux kit. But yes, packets also provide the Dell servers and HP servers, right? There I can push it through Redfish. So let's talk about Moppy tool. I think Nipendra has already covered it, so I just will go through it. So just think about a Linux system, the Linux boot process, right? Initially when you boot the Linux machine, this is what you need actually. When you say kernel, you need a kernel, right? Init is something is the first the process which starts. So that is what we are trying to mention here. And container D has become very stable, and that is the reason where today what the container D supports, you are going to see in terms of the Linux kit itself. So I think there has been a lot of talk about the container D, so I'm not going to touch upon that. On boot is something, if you have any service which you want to start through the boot time, this is on boot. So this is an example of a Redis server. This was demonstrated in DockerCon, where you have a kernel, and the kernel is long-term support kernel, which we haven't taken, but you can build your own kernel also. And these two parts are basically not running inside the containers. So except these parts, and then you have on boot. In on boot, basically, what it is specifying, what we are trying to specify is like networking services has to be started during the boot time. So that is where we are trying to do this. And then we have services, and these are basically the services which you want to run once the OS comes up, right? So Getty is the one. So what they have done, this is a very latest, like 2 weeks back only the Getty was introduced, where your login credentials is also containerized. Means this container is going to provide you with so here if you remove this insecure is equal to true and you add the password, which I am going to demonstrate, that it will ask you for a username and password and you can log in. So this was something which came like 2 weeks back. And then you have a Redis running. I will go through like how this packages, how we reach to this step, or from where these images are coming from. So I have a slide for that. So I'm going to talk about packages. So packages can be coming straight from the Docker Hub images. So if you go hub.docker.com/Linux kit, you will see all the packages. And these are basically on Alpine, but you can create your own Ubuntu also. So I haven't tried that, but there is an example which is in the Linux kit repository. And if you see, all these images have been standardized in such a way. Why? Because the security is a major part here. So since we are talking about packages, we talk about signing the packages, right? So there is a separate security group, and you can get involved with that meeting also. There are in YouTube, you will find a lot of videos. So every week they are recording and they are putting the reports under the Linux kit. So if you go into the Linux kit, you will see all those reports. And Moppy, earlier the Moppy website was like, it was not so much good, but now they have really they have put it in the right way. You can get all the reports and all there also. This is very important part if you are new to multi-stage build, so that usually what happens, right, when you build any packages, right, or when you're trying to build any containers through Docker file, so whatever the build environment also gets shipped with the containers, right? So multi-stage build will probably like the DSCP we have seen, DSCP will be just like 3 MB, less than 3 MB. So multi-stage build, I will show you an example how where the multi-stage build has been used to make the package small. And the content hash, this is an entry which you can see, like the trust entry which you might have seen in the end of the YAML file. This is what is talking about. And there are a lot of new security, because security aspects actually it needs another session for that, because there has been a lot of things which is happening. Let me. So what time? How much time?
10 more minutes.
10 more minutes. Okay. So this is probably I can show because it is connected to my mobile. So what I have done is I have recorded it. So you can go to play with Moppy. So let me show you. Where is it? Okay, so for you to get started, this is a tool which you can use in any of the demos and all. It is not displaying.
That icon there is there top for the Wi-Fi, right? There's an icon there. Go to Wi-Fi, the top right. There's an icon there on the right side of the Wi-Fi. Click on that, and you can share.
Mirror.
Okay.
New to Mac. Okay, so so this is how the by default, if you go to playwithmoppy.com, you will see this interface. It's just like a play with Docker interface if you are comfortable with that. So by default, it opens the Redis server. This was demonstrated in the DockerCon. And what you have to do is on the right hand side is what you can type your command and you can pull your project and do. But what I'm going to do is you just have to say build, and it should start building at the right hand side. Okay, it is slow.
The command which I was showing earlier.
Yeah, it's like a very similar to Moppy build and then the YAML file, right? And then you can provide output. Earlier, there was a flexibility, or I think the decision was made where you can specify the output file inside the YAML, but they have said like since it is supporting a lot of output files, so you can go ahead and say Moppy build -o and then whatever the output you want. So you build it, and then you can just say Linux Kit run, or click on the run, and it should help you to build this particular image. And this image is going to have a Redis as a container.
What do I need to do for the volumes? Let's say I have a lot of disks attached to my bare metal. I want to mount them to my containers.
Yeah. So again, it has to be bind mount, and it will go under the YAML.
Okay.
So I have two issues which I raised, because I was heavily working on Registry for the persistent storage, and still it is not fixed. So, but it is you can have an external disk.
Okay. And same is the case for NFS volumes also.
Yes. External disk is already there. You can go to. So this is how it looks like in the Linux Kit examples. You will see all these examples package Redis OS. This is what we are using now, and GCP and Docker. So let me try to. Okay. So I will pick the Getty one, getty.yml. So this is done, and I can do a containers ls, and it should show me this. I can say container exec -t, and then Redis search, and say ping. Sorry. Okay, I can go inside this one. So the same command runs here. Let me pick up the Getty example. So if you see here,
Increase the font.
It's not visible. I think it will go.
Not do it.
So if you see the service, right, the getty service where you can go ahead and specify the password, right? If you see it here. So if I take this, this will be by default. It is like A B C D E F G H. So let us bring up and see whether it prompts us for the login, because this is very important. Where you it should not be every time you log in as a root by default. So it should be like it should ask for a credential, right? So that is what the we use a getty for. Let me copy it. So you can basically pick it up and quite slow. Slow. Okay. So most probably you can go to any of the entries and make the changes, and based on that, your on the right hand side you can get your images. This is just for a test environment, right? But if you really want to see like what are the other stuff, so I have a blog which is written here, uh, Google Cloud Platform, and this is how it looks like, where you have to first have a Google Cloud SDK platform which has to be installed in .OTAP, because you are going to authenticate, right? Once you authenticate it, all you have to do is basically go ahead and this is the step where you have to install. If you are doing in the Mac machine, you just install Linuxkit and Moppy tool, and it is just like 2 commands. You can use a view of that, and then build this image, create a bucket under the Google Cloud. The same applies for the AWS. We have to go and create a storage bucket and stuff like that, and then you upload this image to the GCP bucket and initiate a GCP instance from the Linuxkit. And you should be able to, and you can, since I took Docker services running inside it. So Docker, whatever you see the Docker, it is like a community edition, standard 1706. I think it should come, because yesterday there was a kind of a pull request for this. So then on top of that, I have run the Portainer. So Portainer is a fancy UI. So this is one example, and same applies for Azure and all those platforms. Okay, so if you see here, it asks for the login password, right? So I can go ahead and provide this, and you should be in. So in the same way, this is the one. So these are basically the blogs which I have written. Related to the InfraKit, again, now there is a Linuxkit playbook in InfraKit. So if you go and install InfraKit in your environment, you will see a Linuxkit playbook which you can import it, and that makes your Moby and Linuxkit installation as a kind of an you will see a kind of a real automation which is happening to build up your infrastructure. And AWS platform, I have a blog written for Linuxkit packaging system, which goes to each and every. I can show you this. Devendra, I have 5 minutes or done?
No, man, 2 minutes.
Okay, so I will pick up one simple package to just demonstrate you. So if you go to the Linuxkit/package, you have, I will take an open NTPD, and you go to the Docker file. So this is where you will see a multi-stage build.
So we have a session today, multi-stage build.
Multi-stage build?
Okay.
Okay.
Yeah, there's a session.
So this is something actually what is happening when you say Linux kernel or whatever the images you are adding, right, from where it is built, you can build your own itself here. So this example shows in terms of NTPD. So it uses basically the BusyBox. It uses a BusyBox and Alpine as a base layout, and then runs a BusyBox, then open NTPD. You can go here and make the changes, and it outputs to the directory called as /output. And this is from the scratch. They have you can specify from the scratch from a very kind of a very minimal OS, and then OS image, and then you can copy all those built environment to this, and you have this service which is running. So this is earlier the capabilities we added into the YAML file, but right now what they have done is they have added the label. So you can pass all this thing, and your YAML file is going to be very clean now, because YAML file, one of the thing which I have seen is like most of the time you keep on adding and it becomes big because you are going to add a lot of services, right? So this is a file basically how you are doing the packaging system. So I think I'm pretty much done. So feel free to contribute in this for LinuxGate, because there are a lot of use cases which I can see coming in. There are around, like, every day I see in average like 10 to 15 new issues which is raised and people want it. And now there has been if you see these blueprints, this is where you keep an eye on this. Why? Because now we have a Docker for Mac if you want to build it. So you will see all those community editions coming into this folder. So right now there is only one, and you have a lot of examples. If you want to build your own kernel, this is a kernel. So packaging is done with PKG, and then you have a projects, the SSH and Nginx. So feel free to contribute on this. And we have one more thing here, the reports. Every week we have they have a meeting and they dump all these logs into this. So yeah, I'm pretty much done with this. Good.
Again, thanks IBM for sponsoring the space and tea, coffee in the lunch today. So I'd like to call Sudipta here and speak a few things about maybe IBM or what they're doing in the open source for the content.
Yeah, thanks, Nipendra. So just a couple of things. So IBM itself is really huge, right? So just to give you perspective, the group which is organizing this, or group which basically deals with a lot of the Linux specific, Docker specific things. So we are what we call the IBM labs, labs part of that thing. Particularly within, so this is the systems labs, and within the systems lab we have a Linux Technology Center. It's a worldwide team spread mainly US, India, and Australia. And our particular team, we are doing a couple of pretty cool things. At this recent DockerCon in Austin, there was this announcement about the multi-arc manifest, which some of our developers are collaborating with Docker to do. We are doing some cool stuff on the open tracing part, the tracing with this. So we are getting the notion of perf events into the tracing community. That's also some of the work which is done. So it's a small group, but I think we are doing some pretty cool stuff here. And because if you want to know more, some of us are here. We can interlock in the breaks. So we have the tea break right now, and we'll have lunch served.
3 minutes break, maybe.
And we'll have a lunch at around 1:30.
Yeah,
whenever we are.
Yeah. Okay. Thank you. So we'll meet back at 11:30. 11:30 we'll come back. 14 minutes. This side?
Yeah.
Coffee is here and washroom is on the right side. I mean, on your left. That's room, right?
So in that case, the routing is responsible or you need something like
Kubernetes or some engine which talks to the container API.
So yes, I would say it all depends on container because in terms of Docker, we have restart on this, we have go and specify. But here everything depends on the container and container D is coming up very fast. That is the reason I want to focus on the container D because Kubernetes and all those things they are still part of CM. So in this you have your container D has to be there. So container D I think right now they have stable views. So that is why earlier it was completely on C.
Container D is still it's still just like
Yes,
API,
yes, yes.
and still it's
So because of this, there will be a lot more activity. Which the container D, you will see the lot more activity.
because the source of the code is not with the container D, if I'm not wrong. Because if you are putting, like if you are telling Linux kit to run something to the container D, like who owns the source of code that okay, these are the services like the desired one and the actual state. Then who handles those parts?
Look, for that again, you have bucket it's but as of now, doing of the services, it has like two unexpected things right now they have to catch up with the container D, what is coming with container D also. But in this case, maybe the infra gate plus container D, they have to
Yeah, it will take some time. He said that target date
still it's like very young, I would say very young, because what we are trying to do is whatever we did with the Docker, we are trying to again see whether we will have this feature with Linux kit or not, or Moppy or not. But it has just started, and the Swarm is also coming with a big where you can go ahead and bring up the Swarm services. Swarm is a services.
Because with Docker, the source of code is still the Docker.
Because application
Docker devil knows everything that fits services.
Yes. So here it is like container D. Now it will start. Now you will see. Hey. Netscape on Windows, but as of now it's the Hyper. Because now Netscape starting for this kernel is kernel of Windows. Straight away. If you go to the under the Linux kit, just yesterday one guy has posted the steps. Follow that steps. And but again,
just knowing the technology and do you have Windows? Yeah, it's not working on Windows. I'll give you my do you have on your
Currently, I have connected to my mobile.
yeah, let's try it. This one does not work.
You can put your
Yeah. Sure. Training. You connect training. Docker Kubernetes, Windows, receivers.
Windows last week only we had one.
Yes.
From Windows itself.
So it's same like
Okay.
But looks promising.
Sure. More ecosystem. You can expect more things happening at this time. As of now, Kubernetes is one where
What is happening?
is it?
Yeah.
Don't push it to YouTube.
It's already live.
So Kubernetes is something for a long time. Yeah. Swarm is, say, the company said this 4 years. There was a time when Kubernetes used Swarm while containers and all.
I'm searching. Called a few folks. Okay.
So that would be a problem. Then every year you see that 2 or 3 projects is there. Moppy is one thing which they have to do. They have to so this. So I'm a part of boot chemistry. There's a lot of players in terms of documents. Yeah. So there was a doctor and business stock. Yeah, they stopped it. It's like funding. But Infinite is all stuff which is here about that is totally distributed. But otherwise, you can use X-ray and that is a very useful. X-ray, you can use a lot of software defined storages and software defined storages. Scale out. 4 OS. What works? Okay, okay. Yeah, that's good. So there are a lot of things happening. Then we have right now they are just aligning it. They're busy aligning it for it. You will be there about maybe the next because that is one big
Display port or HDMI port? HDMI port to connect to this laptop, right? I need to connect to projector. What to put?
You have given the
Yeah.
ಅದೇ ನಾನು ನೀವು ನೋಡಲ್ಲ ಅದು ಮಾಡಿ
Yeah, we'll see that one. We'll talk about that. And moreover, right, I have to just enable and just RAM. What I did is I installed a VMware. And upon that, I installed machines and Docker.
Okay.
So in Linux, Docker is working fine, but in Windows again we use the Hyper-V feature, right? So the mobile Linux is just switching on and switching off. So Docker is never up inside the VMware world. You may ask me why you use the VMware, you can use the Hyper-V as native virtualization. Bloody Hyper-V will never allow you to do a proper network.
This
VMware just click the NAT, what I want to do is what I want to do is I want to directly connect my Linux directly not HDMI, physical network.
Display to VGA we have. So that I think even your this thing Apple has.
That I have that to USB. It wasn't USB, right?
Not USB, it is actually just a HDMI port. Not HDMI, VGA for the display port.
But on this, on the other side is an USB. I have that. This is what USB.
So we have to transfer it to somebody's laptop.
Girish, how do you have to transfer it to somebody? Because this port nobody has.
You'll have to transfer it to because I have all the demos. Because those demos I can't transfer in advance, it will take a lot of time. We have to check with Nipendra. Maybe if you take some time and try to identify that, we can have some other session now and later I can do the next session.
You don't have this this connect, right?
Linux or Docker
HDMI to USB or
mobile Linux is not switch off.
see if the project has a.
This
one has a. We'll have to see if this one has a VGA port, HDMI port. It has a USB. HDMI is there. This one, yeah. You can have to direct.
Okay, how to do it?
ಅದನ್ನ ಇದನ್ನ ತೆಗೆದ್ಬಿಟ್ಟು ಇದನ್ನ
ಇದೊಂದು ಪ್ರೊಜೆಕ್ಟರ್ ಬರುತ್ತೆ ಎಲ್ಲದರಲ್ಲೂ ಬರಲ್ಲ.
ಆಯ್ತು ಸದ್ಯಕ್ಕೆ ಸಾಕು.
you cannot
ಅದನ್ನ ಮೇಲಕ್ಕೆ ಹಾಕ್ಬೇಕು ಅದು
ಇಲ್ಲ
Can I just check now?
Great.
Okay, yeah, thanks.
Okay, so only this will work, but I think that's okay.
It's okay, fine.
Okay, but after this again you have to switch it back.
No, there is no setting. Just need to remove the cable. That's it.
So we selected SDY.
Yeah.
Switching that.
Source ತಗೊಂಡು. Hi all, welcome back. So we'll start the session now. So today I will be talking on the state of Docker in Microsoft Word. Okay. Just give you all minute. Let's check on the
Yeah, we have to.
live streaming part. It's already there, but let's check this works on a Yeah, we'll go ahead.
We'll start.
Yeah, we can start.
Yeah. Okay. So today I'll be talking on the state of Docker in Microsoft Word. My name is Girish Kauder. I work in a company called Xperit. Xperit is a consultancy firm. Basically, it specializes in the latest Microsoft technology. So this is my Twitter handle. If you have any questions, clarification regarding any of those things, what we discussed today, please feel free to contact me.
You can use the mic.
Hello. Hello. Okay. Can you hear me now? Okay. Thanks. Can you hear me now? Yeah. So this is how the agenda looks. So basically, I will do it in three parts. In the first part, we will see the basics of Docker. I think most of you are Docker experts here. So I will try to skip some of the slides. If you feel if you need any more information on some of the slides, you can ask questions and I'll explain more about that. So in the first section, we will see some of the basic things about Docker and what are the different types of containers in Windows. And in the second section, we will see how to Dockerize ASP.NET applications, the full framework application as well as ASP.NET core application, which runs cross-platform. So and in the last section, we will see the different deployment options that are available for containers in Microsoft world. Specifically, I will talk about Kubernetes, which is open source and which is also a popular container orchestration engine. So before starting my session, I want to know how many of you are working on Microsoft Stack. Okay.
I work on Hyper-V, Microsoft Hyper-V and Azure.
Okay. 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 So there are a few people. This slides talk about Docker. Maybe everybody knows about Docker, right? I can skip this slide.
Yep.
Yep. And this is how the architecture in Linux looks. Again, I think you will be familiar with these terms, all these terms. So I'll go ahead with the architecture in Windows. So in Windows, we had something called as control groups and namespaces, but they were not as par with the Linux operating system. So for Windows Server 2016 and Windows 10, they have to tweak it a lot. And one of the features that was missing in Windows was the layer capabilities, which they have to introduce this new feature in Windows. And if you see here, there is something called as compute service. So that is not present in the Linux architecture. So basically, Microsoft came up with the compute service basically for two reasons. One was when Microsoft started working on the support for Windows containers, there were a different implementation of Docker engine. For example, the Docker itself has its own implementation and Rocket had its own different implementation. So to support both of them, they came up something called as compute service so that they can handle it internally. And the other reason why they came up with compute service was because of Hyper-V isolation, which we will see in a moment. So, this is the Windows container setup. So basically, we will have a kernel. On top of that, we will have Docker engine. So here we can run containers, Windows Server containers. We can run any number of Windows Server containers. So the problem with Windows Server containers is, sorry, though they provide a process level isolation, they do not provide the isolation that is there in virtual machines. So Microsoft came up with something called as Hyper-V container. So it's basically the same container, but in Hyper-V container, we also run a virtual machine. So here it provides the same isolation as that of a virtual machine. So Microsoft also what they did is they are coming up a Hyper-V isolation with a Linux kernel. So what we can do now is we can run both Linux container and Windows container side by side. This is a new feature which will be coming later this year.
It's like in Hyper-V containers itself, we can run both Windows and Linux.
Like, yeah. So as of now, you can run only Hyper-V container with Windows. So later, in this year, they will come up with the Hyper-V or Hyper-V isolation with a Linux kernel. Basically, it will use the Linux operating system. Yeah, it's based on top of that. Yeah.
So Windows 10 had launched this Ubuntu LXSS container.
Come again,
as a-
if you can.
Windows had launched the Ubuntu container also as a part of the development kit. Right? The happy,
What container?
It's not a container; it's a subsystem, right? They call it as a subsystem, Linux subsystem.
Yeah, but
and
it runs on an SS platform module, right? It's like a lightweight container module.
Okay, I'm not aware of that. Yeah.
Not only that one, even you said that from the next year onwards, Linux and Windows 10 they can run side by side.
Yeah.
But currently, I don't know. We call it side by side, but currently I'm using Docker in Windows, and I installed some Windows application,
Yeah.
and as well as I'm running Linux applications also.
So currently, this feature is not available. Hyper-V isolation with Linux kernel. That will come later in this year. So currently, you can run only Windows container. On top of if you are installing Docker for Windows, it will create an in the hypervisor. It will create basically a Linux operating system, and basically you will be using that. But Hyper-V support will be coming later this year. Yeah.
Okay.
So this is the basic architecture of how Docker works. So we will give a Docker pull command, and it will pull the registry, pull the image from a Docker registry, and put it on the host machine. And once we say Docker run, it will run as a container. Yeah. And also one of the important concepts of Docker is the layering system. So basically, whenever you want to create a custom Docker image, you will use a base image, and on top of that, you will install all your application dependencies, and on top of that, you will install your application binaries. And one important point here is, so once you create this image, you will not be able to modify any of these layers. So on top of application binaries, you will be able to do some changes, but yeah, these layers you can't do any changes. So this way, it will work the same across different environments. We'll see a demo here. We'll see basically the containers in a Windows Server 2016, which are Windows Server containers, and then we will see containers on Windows 10, which are Hyper-V containers. So basically, I have created a virtual machine in Azure. This is Windows Server 2016. Here I have installed Docker. It's taking some time to load. Internet, let me see.
Working for you or not yet? I'll give you the.
I have connected. Okay, so the Docker command is running. So what I will do here is I have pulled different images given by Microsoft. So if I do Docker images, it's okay. We can see here we have different images. One is called as Nano Server, and the other one is Windows Server Core. Nano Server is the smallest the server container image given by Microsoft. It's around 1.2 GB, and the Windows Server Core is around 10 GB.
Yeah, they call it the smallest.
Yeah, it's the smallest. Yeah. So I'll run this.
Unfortunately, the 1.2 GB don't have a GUI.
Yeah, it don't have a GUI. Yeah. So I'm running this Nano Server container here. So basically, in this demo, what we will see is we'll see the Windows Server containers and how they are not completely isolated when compared to a virtual machine. So I'll run few commands here. I'll go to PowerShell. Yeah.
Still more.
And if possible, just change the background to white.
That background, it's running in the container by default. It's black. Yeah. So yeah, it's okay. Okay. So if I do a get process here, currently I'm running a container, and here we can see the different processes that are running. If you see here, one of the processes is called as CMD with ID 5968, and so this was inside the container. Now I am on the host, and if I go to the processes in the host machine, um, I am able to see that particular process on my host. So what I can do is, if I end this task, so that container which is running will exit it out. So basically, though it provides the process isolation, it's not completely isolated when compared to a VM. So I'll do this end task. So if you see here, it exited out of that container. So if I say docker ps, I don't see any of the container running. Yeah. So these are Windows Server container. Um, so Microsoft came up with the Hyper-V container so that you can have the same kind of isolation that of a VM, and also you can use the same Docker APIs. Yeah, it's just only one additional flag which you need to send. So now I'll go to Windows 10 machine. Currently, I'm running one of the container. So if I do a get process here, this is a Hyper-V container. If I do a get process, and if you see the same process, CMD process, which is 1588, and if I try to see it in the host machine, it will not be visible. So it's basically that isolation which Microsoft is providing. Yeah. Any questions here?
So, with respect to this, so Hyper-V containers are safer than the normal general
Windows Server container.
containers,
For some, if you think of the use cases, like if you are a hosting company, right, and if you want to support multi-tenancy, and also if there are any compliancy reason that you need to provide hardware isolation, so then you can go for Hyper-V containers.
How is the scaling being taken care of?
It's the same API. So whatever you use, right, Docker Compose, Scale, or the different orchestration engine, right, the same way it works. It's just that that compute service, what I talked earlier, right, they will pass this additional flag to that, and internally it will create a Hyper-V container.
And once the container is running, can we expose some of, if we need, can we expose some of the processes to the core kernel? I mean, to the external system hosting the container. Like in case I want some of the services to be visible to my base system.
That you will do the same way how you were doing it earlier. So I think that it just work as on a VM. It's basically a specialized container which will work very fast, similar to that of a Docker container. So yeah, with that. So how many of you are using Visual Studio for deployment and all here?
VS Code.
Yes. Nobody is using Visual Studio. Okay. Yeah. So next, a few of my demos we're showcasing that using Visual Studio, how to create Docker file and how to create Docker Compose. So I'll just briefly explain about those things, and then we can, yeah. So the next demo is here we will see how to containerize a ASP.NET application. So basically I will be using an image called Microsoft ASP.NET latest. So here we can use either the latest .NET framework or the old framework by giving the tag names here. So internally it uses Windows Server Core and IIS. So we'll see this particular demo. So here in the Visual Studio project, I have this Docker file. Here I'm using that base image. On top of that, I am giving the commands. This is basically to take the files, the published files in Visual Studio, and run it in a container. And then I'm exposing port 80. So this is the ASP.NET MEC application. So here I will build this custom image and run it as a container. Let's say Docker build. I will give a name as my Docker app, and I will give the path as the current path, wherein it will look for the Docker file. Okay, this is because I'm not in the correct directory path, so I'll go to that particular path, or I can take it from here. I'll go here only. Now I will run the same command. So basically, I had previously run this container, so it had already cached all the layers. So now I will run it as a container. I will specify the port numbers here. The port of the host machine should map to the port of the container. Now the application is running. The Docker container is running. If I do a Docker PS, okay. So now what I will do is I will get that IP address of the container, Docker inspect. And if I run this particular IP address in my browser, I'll be able to see the application. So this is taking some time. In the meanwhile, so I will skip one of the demos. Again, here in that particular demo, I was planning to show how to Dockerize the .NET Core application, which is based on the microservice architecture and also which works on cross-platform. So I'll skip that one. And yeah, we will see the different deployment options that are available for containers. So in Azure, we have something called as Azure App Service. This is basically the platform as a service offering from Microsoft. Currently, we can run Windows, only the Linux container, and the Windows container support is coming later. And the one more service which we can use for deploying is called as Azure Server Fabric. This is the orchestration engine which is built by Microsoft, and also this service is being used by many of the Docker service, many of the Microsoft service like Azure DB, and also it's a backend for the Skype application. And the other thing here is Azure Container Service. So here we get support for all the popular open source orchestration engines like Docker Swarm, Kubernetes, and DCOS Marathon. So today I'll go through the basics of Kubernetes. Before that, let's see if our application is running. So basically, this is the MSC store. Web app, which is running in a container. Yeah. So yeah, we'll see the basics of Kubernetes. So basically, some of the advantages that the orchestration engine provides are the fault tolerance, service discovery, and also it can be like for scaling and all. So the Kubernetes master does that for us, and we have different nodes running which will run the containers. And these containers, we can pull it from either a Docker hub, which is a public registry, or we can pull it from a private registry. And if you see here, we have different clients which will talk to the Kubernetes master. We have something called a CLI, which is basically kubectl, which we will see in the demo. And also we have something called as UI. A dashboard is provided to talk to the Kubernetes master. And we have the REST APIs. And yeah, these are some of the terms which are being used in Kubernetes. So some of them are, it's called as, one of them is called as pods. So basically that's the basic unit of deployment. So if you see in Docker, the container is the basic unit of deployment, but here in Kubernetes, it's a pod. So it can be a collection of containers again. And we have something called as replication controller. So basically, this will make sure that the system is in the desired state. And we have called something called as deployment and services. So which we will see it in a demo. So now what I will do is the same music store application which we earlier Dockerized. I will run it in Kubernetes. But it's okay, I'll stand there.
You can see if you want.
Yes, so I have already created a Kubernetes cluster, which is a Windows cluster. Now we can create
running on Windows.
On Windows, yeah.
So is there any already a profile for that? You can just pick it up, or you have to convert manually.
We can use different APIs provided by Azure. Basically, one is called as Azure CLI. It provides a CLI. We just use the commands over there, and we specify the master, the number of clusters, everything, and it will automatically create a for us. Yeah.
You say Azure create 3 node cluster and that's all.
That's it. Yeah, it's very simple.
Windows.
Yeah, it's like 4 to 5 lines of commands are there, which will create a cluster for us. Yeah.
It will automatically create Kubernetes cluster.
Kubernetes cluster, yeah. So I have already created one. If I say get nodes. So yeah, here I have one master and 2 nodes. So before that, I think I forgot to discuss about one thing. Yeah. So the way the deployment works in Kubernetes is it's in the form of declarative form. So basically, we provide a JSON file or an YAML file and describe what are the things we need to run as part of that deployment. So basically, we'll specify the containers, the different services that we need. So we will provide those files, and the Kubernetes master will take care of running those containers. So here I have created one of the files for deployment. So basically, here I am giving the container it should run, and also specifying a registry input, because since I am using a private registry which is hosted in Azure, so I am specifically giving the key for the secret which is used to connect to the registry, and also we can specify the number of instances of container the cluster should run. So that is specified here in replicas. So what I will do is I'll give this file to the Kubernetes master, and it will create a deployment. Yeah.
What exactly are you using that registry for?
Registry, it's used for storing the Docker image. So by default, the Kubernetes will pick it from the Docker hub. So I have created a private registry in Azure. It's called as Azure Container Registry, and to connect to that, we have a secret and password. So we need to create that one.
That is something you get with Azure subscription.
We'll get, once we create that private registry, right? We will get the username and password.
So it's like basically you're storing a different repository.
No, it's like in Azure. If you compare with different clouds, right, like Google and Amazon, they have their own private registry, right? Google Container Registry. The same way, we have something called as Azure Container Registry, which will store all the containers. It's similar to a Docker Hub registry.
I was comparing it to DTR. So can we store these images on DTR also?
What is DTR?
Worker trusted.
Yeah, you can.
Yeah.
Image can be anywhere, right? But it's just to be in the cloud. It has to be in the cloud. Rather than Azure.
There was a problem with the would have not updated. We were trying to upload this push those images on DTR.
Okay.
So
Okay. Yeah. Maybe.
So basically, right now the Docker built image that you have got, you have pushed it into the registry.
Registry, yeah. So maybe what I will do is I can show that to you. So here this is the Azure portal. If I go to the resource, this is Azure Container Registry. So if I go to repository, so these are the images which I have pushed into that particular registry. Yeah, the one which I have pushed is my Docker app, which we created earlier. Yeah. So what now I'll do is I'll create a deployment using kubectl command. So the deployment is created. Now it will create the different pods and the replicas what we mentioned in that particular file. So it's still creating. Yeah. Because since the image size is very big, right, it takes some time to create those containers. Yeah, it's the pods are running. The next one is we will create a service. So basically, the service is used to expose the pods to the outside user. So here we will specify the load balancer, and also it can be used for other reasons as well, like to connect between two pods. So in this demo, I'm just exposing that particular pod as part of the load balancer. So I'll create that particular service. Okay, so I think the service already exists. So we can just say Kubernetes get service. Okay, so this is the IP address which we can use to see the applications. Yeah. Meanwhile, till the application comes, if you have any questions, we can discuss on that. I'm planning to show one more feature wherein the orchestration engine by defaultly provides the fault tolerance out of the box. So what I will do is I'll delete those pods, and again the pods will be created by the Kubernetes cluster, which we can see. Other than that, I think I'm done with the presentation. Yeah. If you have any questions, you can ask them.
So these are Windows Server containers itself.
Yeah.
Will there be a way to use this to also run Hyper-V containers? Like the same approach you use, I guess that would be possible only with native Docker, not with Kubernetes.
So we can use the same if you're talking about the different types of container, right? Windows Server container and Hyper-V.
Right.
The same container can be used as a Hyper-V. It's like both are compatible. We need to just add one switch to it. So for example, in your local development, you can run it as a Windows Server container, and in production, we can make it as a Hyper-V container by just passing one flag.
But Kubernetes can manage that.
Kubernetes, I'm not sure. It will be managed on Windows cluster, but not on Linux cluster.
Okay.
Yeah, because Windows has that inbuilt feature, right, wherein it will